Hey guys, we are going to start off this chapter talking about triangles and some of their properties. So first off, we need to define what a triangle is. And if you will draw a triangle on your paper using your straight edge, a triangle, as most of you know, is a polygon with three sides. I can label this triangle at its vertices. I'm going to put point A, point B, and point C. So then I can call this triangle A, B, C. And that order is not important. You can call it B, A, C, C, A, B, whatever you want. Shorthand for triangle, though, is just a little triangle symbol. So triangle A, B, C would work as well. Okay, so some ways to classify triangles. If we're looking at their sides, when we are classifying, we have scalene, isosceles, and equilateral. So a scalene triangle means that none of the sides are the same. So all different lengths, we have 0 congruent sides. And an isosceles triangle, 2 of the sides are the same, so we have at least 2 congruent sides. For an equilateral triangle, all of the sides are the same, so we have 3 congruent sides. So that's to classify by sides. What if we want to classify by angles? So in an acute triangle, all of the angles are acute, so we have 3 acute angles. In a right triangle, we don't have all of the angles being right angles. We only have 1 right angle. Those other 2 angles are going to be acute. In an obtuse triangle, we have 1 obtuse angle, and those other 2 angles are acute. An equilateral triangle, all of the angles are the same. Equiangular triangle, all of the angles are the same. So 3 congruent angles, just like in an equilateral, where we had 3 congruent sides. Okay, so this says classify the triangular shape of the shuffleboard scoring area in the diagram by its sides and by its angles. So I see those tick marks on the sides. That means that 2 of the sides are the same, which would make it an isosceles triangle. And if I look at those angles, they all look to be less than 90 degrees, so they are acute. So this triangle would be an acute isosceles triangle. Okay, so this says classify triangle RST by its sides. Then determine if the triangle is a right triangle. Okay, so if we're classifying by sides, we need to know about the side lengths. And so step 1 says use the distance formula to find the side lengths. So it's kind of set this up for us, and I'm going to go ahead and fill in the blanks here since your distance formula is written out for you. So RT, we're going to subtract our x value. So I look up at point RT, and I have 3, and then I'm going to subtract my -3. Those are my x values of R and T. Then I put a plus sign in between, and my y values, I need to start with the same point. So I started with point T, so for y I'm going to start with point T again, so -1 minus 3. And I'm going to close that and square it. Take care of what's inside the parentheses. So 3 minus -3 gives me 6. I still need to square that. -1 minus 3 gives me -4. And I need to square that. So 6 squared is 36. -4 squared is positive 16. So 36 plus 16 is 52. And yes, we can reduce that, but what we really just want to see is, are the side lengths the same? So if we get another square root of 52, then we'll be able to see if it matches. Okay, so RS then, I'm going to find those 2 points. So I'm going to subtract my x values. So I'm going to do 5 minus a negative 3. And then I'm going to do 2 minus 3. So 5 minus a negative 3 is 8. And 2 minus 3 is negative 1. So 8 squared gives me 64. And negative 1 squared is positive 1, so I get 65. So far, no matches. So let's see about this third side. So if we know that those two don't match, then we know that it cannot be an equilateral triangle because we would need all 3 to match. So ST. So I'm going to do 2 minus a negative 1. Oh, sorry, those are the y values. I'm going to do the x values first. So I'll do 5 minus 3 and square it. And then I'll do 2 minus a negative 1 and square it. Okay, so 5 minus 3 is 2. And then 2 minus a negative 1 is 3. So 2 squared gives me 4. And 3 squared gives me 9. So I have the square root of 13. So that tells me that none of the sides are the same. So if none of the sides are the same, flip back and look at classifying by sides. That means we have a scalene triangle. Now, it says check for right angles. I want you to think back to last chapter. When we checked for right angles, we were looking for perpendicular lines, and perpendicular lines have slopes that are opposite reciprocals. Now we could check all 3, but what I would encourage you to do is check the 2 lines that look like they might be a right angle. So it looks like at T, there might be a right angle. So I'm going to check segment RT and ST and see if their slopes are opposite reciprocals. If they're not, then I'll go ahead and find the slope of RS and see if maybe one of those angles is an opposite reciprocal as well. But I'm going to start with RT and ST. So the slope of RT. Remember that our slope formula subtracts the y values. So I'm going to do 3 minus a negative 1 over, and then I started with point R, so I'm going to start with point R again, negative 3 minus 3. So 3 minus a negative 1 is 4. Negative 3 minus 3 is negative 6. I know I can reduce that. Those are both even. So I end up with negative 2 over 3. Okay, then I'm going to try the same thing with the slope of ST. So take my y values. I'm doing 2 minus a negative 1 over 5 minus 3. So 2 minus a negative 1 is 3. 5 minus 3 is 2. Now recall, opposite reciprocals means one's positive, one's negative, which they are, and the fraction has flipped over, which also happened here. So yes, we have a right angle. So that means since we have one right angle, that we have a right triangle. But also from checking our lengths, we said they're not the same, so we have a scalene triangle. So here we have a right scalene triangle. Okay, so the triangle sum theorem, and you guys may know this from a previous math class, says that when you add all of the angles together, they add up to 180 degrees. So the measure of angle A plus the measure of angle B plus the measure of angle C is 180 degrees. So the sum of the measures of the interior angles of a triangle is 180 degrees. Okay, so another theorem we're looking at then is that if we know the 3 angles inside add up to 180, what do we know about this angle outside right here? So, and it turns out that there's a special property here, and we're going to go through why this works together in class, but this angle 1 is equal to this angle here and this angle here added together. So the measure of angle A plus the measure of angle B equals that measure of angle 1 that's on the exterior. So this is called the exterior angle theorem, and it says the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. Non-adjacent interior angles. So let's test out an example here. So this is saying then that outside angle, 3x minus 9, is equal to the other two angles inside that aren't touching it. So 73 and x added together. So now we're just doing algebra. So minus x on both sides. 2x minus 9 equals 73. Add 9 to both sides. 2x equals 82. Divide by 2. X equals 41. We're not done here though because it wants this outside angle, DCB. So I need to do 3 times 41 minus 9. So 3 times 41 minus 9 tells me the measure of angle DCB is 114 degrees. There's your final answer there. Okay, new term here. And I've heard this pronounced several different ways. You can pronounce it corollary or corollary. I tend to go with corollary. It's a statement that can be proven easily using the theorem. Statement that can be proven easily using the theorem. So the corollary to the triangle sum theorem, where all of the angles add up to 180, is that if we have a right triangle, so we know this is 90 degrees, then we know the other two angles have to add up to 90 degrees if we want the whole thing to total 180. So the acute angles of a right triangle are, and you can use the word complementary here, you could say 90 degrees. We're going to go with our vocab here, complementary. All right, so let's put this into practice. We know the front face of a wheelchair ramp forms a right triangle. The measure of one acute angle in the triangle is 8 times the measure of the other. Find the measure of each acute angle. Okay, so I know that's 90, that right angle. If I call this x because I don't know it, it says the measure of one is 8 times the measure of the other. So if this one is x, then this would be 8 times x. Using our new corollary, we know that if we have a right angle, 8x plus x would have to equal 90. So 9x equals 90. We divide by 9. X equals 10. So one of our angles is 10 degrees. The other angle is 8x. 8 times 10 gives us 80 degrees. So we get 90 degrees there, and then we have our 90-degree angle to give us a total of 180. Okay, I will see you all in class. If you have any questions, as always, please don't hesitate to come in and visit with me. Have a great day.